Hello. Okay, let's look at this problem. You can pause the video and try this question. It's a question involving normal distribution, right? The thickness of papers produced by a machine, right? It's about the thickness of paper. It's normally distributed with a mean of 1.05 millimeter and a standard deviation of 0.02 millimeter, right? Okay. The most important thing that you know that is a normal distribution. Normal distribution is defined to be normal with the mean and the variance, right? Variance is the standard deviation. You go and square it. So as the question giving you the thickness is the x here. The x is the thickness. It's a continuous random variable, right? It's a thickness of the paper is normally distributed with the mean of 1.05, right? Mean of 1.05 millimeter, and the standard deviation. They're giving you the standard deviation. You have to go and square, because this is a variance, right? It's a variance. So this is the format of writing. Then the question asking you to determine, right? Determine the probability that a piece of paper chosen randomly will have a thickness. For question A, it will have a thickness between 1.02 millimeter and 1.09 millimeter, right? It's between this. So that you know that the mean of the thickness of the paper is 1.02, right? At 1.05. So they just want to find the probability that there is a possibility that the thickness of the paper is between 1.02 and 1.09. So this is a normal distribution, right? So we have to standardize the score in order to find the probability here. Means have to change the score x to score z, right? So you know that score z is normally distributed with mean of 0 and standard deviation of 1, right? So you have to understand this, right? So we have to standardize the score. Alright, so to standardize the score, the formula will be z equals to x minus with the mean divided by the standard deviation here. So same thing if you learned this during your secondary school. So 1.02 have to minus away the mean, 1.05 divided by the standard deviation. This is the standard, not include the square. So it's 0.02. Then here will become z, right? Because you have standardized the score. So 1.09 minus with 1.05. The mean for this case, right? This is the mean for this case is 1.05 divided by the standard deviation 0.02, right? So from here, you can know that the score z will in between. So which giving you the value of negative 1.5 and 2, right? Negative 1.5 and 2. So in order to evaluate this by using statistical table for normal distribution, so you have to understand, right? Okay, this is just to guide you so that you know that the mean is 0, right? The mean is 0. So the value is between negative 1.5, right? Negative 1.5 and 2, right? So it's in between this, right? In between this. So this is the same as you take the big one, everything means that the area for the normal distribution under the one, it will be 1. Always give you the value of 1. Minus away the area here, right? Can you see the empty here? So negative 1.5, right? And minus away the area above 2, right? Above 2. Can you see that? There is a 2 empty space here, right? Minus and minus 1, right? So if you want to using statistical table, you have to convert this distribution into the right hand side, right? Means that the negative 1.5, right? Negative 1.5 is the same because they are symmetry about the line 0. So it will be here, 1.5. So which is Pz more than 1.5, right? This one is Pz more than 2, right? So from statistical table, you can find these two values, and that's all you can get the answer for the probability. So refer to table 4, table 3, table of standard normal distribution. So you look at here 1.5, right? So you find the value of 1.5. 1.5 here, which is correspond to 0.0668. 0.0668, right? 1.5 and more than 2, right? 2. So 2, you find the value 2 here will be 0.0228. 0.0228. Alright, by using calculator, if you subtract, you were getting the value of 0.9104. This is in probability, it's actually 91.04%. Means that all the paper that produced by the machine, according to this question, right, they have the mean of 1.05 millimeter, right? Usually the mean. So, but if you see that the percentage here is quite high here, means that most of the paper is within the range. The paper produced, the thickness is between 1.02 millimeter and 1.09 millimeter, right? From the probability, you can see most of the paper, right, will be in this thickness. So this is for part A. Let's look at part B. Alright, okay, let's look at part B. Find the probability that the piece of paper chosen randomly will have a thickness more than 1.08 millimeter or less than 0.992 millimeter. So means that the meaning here is probability that X more than 1.08 millimeter or, right, or probability that is less than, or the thickness can be less than, right, can be less than 0.992 millimeter, right? As this is you can rewrite this to become X greater than 1.08, right? So it's mutually exclusive between these two events, right? The probability of X more than the thickness of the paper is more than 1.0908 is mutually exclusive from the probability of X less than 0.992, right? So you can just write and add here, right? They will not have the same, because this is the thickness. We talk about the probability of the thickness less than 0.992 meter, and this is a thickness more than 1.08 millimeter, right? So it's totally different case. So that's why we can just add up. So all, right? So we just add up less than 0.992 here, right? So definitely, if you want to find probability for this type of cases here, with this mean, we want to using statistical table, we have to convert this into the Z-score, right? By using this formula here. So let's see how to convert this. So we just write this to be probability of Z greater than 1.08 minus with the mean 1.05. This is your mean divided by the standard deviation 0.02, right? Plus with convert becomes score Z. So you take the 0.992 minus with the mean 1.05 divided by the standard deviation 0.02, right? So later on, you know that PZ greater than 1.5. 1.5 for this. If you're using calculator, you calculate, and plus with probability of Z less than negative 2.9. Less than negative 2.9. So you can using this by from statistical table. You can read this from statistical table. It's already greater than a positive value of 1.5, and this one you should do some modification here. So because Z less than, so this is 0, right? 0, the mean. Now standard score Z, right, is middle, always 0, the mean. So this is less than the mean, negative 2.9, right? It's this region, right? So if you want to using statistical table, you have to reflect this onto the right hand side, which will be 2.9, right? 2.9 means that this is the same as this one, or we can say that the probability of Z more than 1.5 plus with the probability of this one, you can change it to become more than 2.9. They have the same value, right? Z less than negative 2.9 and Z more than 2.9 having the same value. So from statistical table, we can find the value easily by using table 3. So 1.5, right? 1.5, 0.0, right? 0.0668 plus with the probability of more greater than 2.9, right? 2.9 is 0.00187 0.00187. So total up these two will give you the answer for this question here. So which we're giving the value of 0.06867, right? 6867. So this one show that you see this is contribute how many percentage, right? This is actually 6.867%. It's a very small amount, right? It's contribute a very small percentage. For the thickness of the paper that more than 1.08 millimeter or less than 0.992 millimeter, either these two, right, is contribute just 6.867%, right? But this is just for your knowledge. So, but the answer here will be 0.0686, right? That's all for this question.